Hello everyone. The headline of this tutorial is evaluating limits. It is useful before we start solving examples and questions to list the rules of evaluating limits. Number one, limit of any constant function k, it is the same constant. Limit x approach to c for k, it is k. Number two, limit for a constant times a function equal to the constant times the limit of the function. Number three, limit of the root of order n of f of x equal to the root of the same order for the limit f of x when x approach to c. Number four, limit for two addition or subtraction function equal to the limit for the first one, add or subtract limit for the second one. Number five, limit x approach to c for the division of two functions f of x over g of x equal to the limit for the numerator over limit of the denominator when x approach to the same number, where limit x approach to c for g of x not equal to 0 because it is in the denominator. Number six, limit of two multiplication function equal to the limit for the first one times limit for the second one. Number seven, limit of the composite function f circle g equal to the limit of the f of g of x equal to the f of limit for g of x, and if the limit of g of x is L, then the answer is f of L. Number eight, trigonometric function, limit sine x when x approach to c is sine c, limit cosine x when x approach to c is cosine c, limit tan x when x approach to c is tan c. Here c not equal to the pi over 2 plus k pi because make the denominator, make the cosine 0. Limit of the exponential function e to the x when x approach to c is e to the c, limit for the logarithmic function ln x when x approach to c is ln c, and number 11, we have three rules for trigonometric function. Sine x over x when x approach to 0 is 1, limit 1 minus cosine x over x when x approach to 0 is 0, limit tan x over x when x approach to 0 is 1. Example, find each limit. Limit x approach to 1 for 3x power 3 minus 2x power 2 plus 4. It is polynomial, so I substitute directly every x with 1. Then the answer is 3, 1 power 3 minus 2, 1 power 2 plus 4 equal to 3 minus 2 plus 4 equal to 5. 3 minus 2, 1, 1 plus 4, 5. Number 2, limit square root x plus 1 over x plus 4. Since the denominator when substitute x with the 3 not equal to 0, then I'll directly substitute every x with 1. The answer is square root 3 plus 1 over the 3 plus 4 equal to square root 4 over 7 equal to 2 over 7. Number 3, limit 2 over x plus 2. Since the denominator when substitute x with 3 not 0, then directly substitute every x with 3. The answer is 2 over 5. Number 4, if f of x equal to 5 minus x, g of x equal to x power 3, find limit composite function g of f of x. Limit g of f of x equal to g of limit f of x when x approach to 1 equal to g of limit f of x is 5 minus x when x approach to 1 equal to, substitute every x with 1, then g of 5 minus 1 equal to g of 4 equal to 4 power 3 equal to 64. Number 5, limit of trigonometry function, limit of sine pi x over 2 when x approach to 1. Substitute directly every x with 1, then the answer is sine pi over 2 times 1. Sine pi over 2 is, this is the graph of sine, this is pi over 2 is 1. Then the answer is 1. Number 6, find the limit of the function 1 over cosine pi x over 6 when x approach to 6. Since the denominator not equal to 0 when substitute x with 6, then directly substitute 1 over cosine pi, 6 pi times 6 over 6, 6 with 6 equal to 1 over cosine pi equal to 1 over negative 1 equal to negative 1. Number 7, given limit of f of x when x approach to c is 27. Find limit of the cube root of f of x when x approach to c. Then limit cube root of f of x when x approach to c equal to cubic root of limit f of x when x approach to c equal to cube root of 27. Since the limit of f of x when x approach to c is 27, then the answer is 3. Find limit f x approach to c for f of x squared. Limit f of x all square when x approach to c equal to limit f of x when x approach to c all power 2 equal to, since the limit is 27, then 27 power 2, find it from calculator. Number 8, limit x minus 5 over x power 2 minus 25 when x approach to 5. If I substitute every x with 5 directly, then the answer is 5 minus 5, 0 over 5 power 2, 25 minus 25, 0. But I can find this limit by analyzing the denominator, difference of 2 square, as x minus 5 over x minus 5, x plus 5. Reduce x plus 5, x minus 5 with x minus 5. Substitute every x with 5. The answer will be 1 over 5 plus 5 equal 1 over 10. Question number 9. Find the limit of the function x power 2 minus 5x plus 4 over x power 2 minus 2x minus 8 when x approach to 4. If we substitute directly every x with 4, then the answer will be 0 over 0, as you see. 4 times 2, 16, minus 5 times 4, 20, plus 4, it is 0. 16 minus 20 minus 4 plus 4, 0, over 4 power 2, 16, minus 2 times 4, 8, minus 8, 16 minus 16 is also 0. But we can find this limit by analyze the numerator and denominator by experiment. as x positive negative, then it is negative 1 4. For the denominator, x negative negative, then positive negative 4 2. We can now reduce x minus 4 with x minus 4, then the limit will be limit x approach to 4 for x minus 1 over x plus 2. Now if I substitute every x with 4, the answer, the denominator not be 0, since 4 plus 2, 6, 4 minus 1, 3 equal to 1 over 2. Number 10. Find the limit for x minus 2 over x plus 2 when x approach to 2. Since the denominator not be 0 when substitute every x with 2, then directly I'll substitute 2 minus 2 over 2 plus 2 equal to 0 over 4 equal to 0. It doesn't matter if the numerator became 0, but the denominator should not be 0 because we cannot divide by 0, and dividing by 0 is undefined. Number 11, find the limit for the function square root x plus 5 minus square root 5 over x. If I directly substitute every x with 0, then 0 plus 5 square root 5 minus square root 5, 0 over 0. But we can solve this kind of limit by multiplying both numerator and denominator by the conjugate of the numerator. The conjugate is the same value of the numbers but with the reverse sign between them. The conjugate of the numerator will be square root x plus 5 plus square root 5. Then multiply also the denominator by the same value, x square root x plus 5 plus square root 5. Now, the answer will be square root x plus 5 times square root x plus 5 is x plus 5 minus time plus negative times positive negative square root 5 times square root 5 is 5. 5 with 5 reduce, the denominator will be x times square root x plus 5 minus square root 5. Reduce x with x. The answer will be, we have a limit here when x approach to 0. Limit x approach to 0 for 1 over square root x plus 5 minus or plus square root 5 equal to, substitute every x with 0, then square root 0 plus 5, 5 square root 5 plus square root 5, 2 square root 5. Number 12, find the limit of the function x plus delta x power 3 minus x power 3 over delta x when delta x approach to 0. If I substitute delta x with 0, then the answer is x power 3 minus x power 3, 0 over 0. But we can solve this kind of limits by opening the bracket in the numerator. I'll set it as x plus delta x power 2 times x plus delta x minus x power 3 over delta x equal to limit delta x approach to 0 times x power 2 plus 2x delta x plus delta x power 2 times x plus delta x minus x power 3 over delta x equal to limit delta x approach 0 for x power 2 times x power 3, x power 2 times delta x power 2 delta x. 2x delta x times x, 2x power 2 delta x, 2x delta x times delta x plus 2x delta x squared. Delta x power 2 times x is x delta x power 2, delta x power 2 times delta x power 3 minus x power 3 over delta x. Reduce x power 3 with x power 3, then limit delta x approach 0, factorize the numerator by delta x, then x power 2 plus 2x power 2 plus 2x delta x plus x delta x plus delta x square over delta x. Delta x with delta x, substitute every delta x with 0. This term will be 0. This will be 0. This will be 0. The answer is x power 2 plus 2x power 2 equal to 3x power 2. Question number 13. Find the limit when x approaches to 0 for 1 over 3 plus x minus 1 over 3 over x. If we substitute every x with 0 directly, then the answer will be 1 over 3 minus 1 over 3, 0 over 0. But we can find this kind of limits by uniting the fraction. Then the answer will be limit x approach to 0, unify the two fractions in the numerator. The common denominator is 3 times 3 plus x. The numerator will be 3 minus 3 plus x over x equal to limit x approach to 0, 3 minus 3 minus x over, let me write it as 3 minus x over 3x, 3 plus x equal to 3 with 3, x with x, limit x approach to 0, negative 1 over 9 plus 3x. Substitute x with 0, then the answer is negative 1 over 9. Question number 14. Find limit when x approaches to 0 for sine x over 5x equal to, take 5 on the denominator outside of the limit. It will be limit x approach to 0 for sine x over x. Since the limit of sine x over x when x approaches to 0 is 1, then the answer is 1 over 5. Question number 15. Find the limit when x approaches to 0 for 3 times 1 minus cosine x over x equal to, take the limit since it is, take 3 outside the limit. Since it is constant, then the limit will be 3 times limit x approaches to 0 for 1 minus cosine x over x. Since the limit of 1 minus cosine x over x when x approaches to 0 is 0, then the answer is 3 times 0 equal to 0. Number 16. Find the limit of cosine x times tan x over x when x approaches to 0. Then I can rewrite this limit as limit x approach to 0 for cosine x times limit tan x over x when x approach to 0. Since limit tan x over x when x approach to 0 is 1, then the answer will be limit when x approach to 0 for cosine x equal to cosine 0 is 1, then the answer is 1. Number 17, find the limit of sine square x over x. Rewrite this limit as limit x approach to 0 sine x times sine x over x equal to limit sine x when x approach to 0 times limit sine x over x when x approach to 0. Since this limit is 1 is equal to 1, then the final answer will be limit sine x when x approach to 0 times 1 is 1. Sine 0 is 0, then the result is 0. Number 18, find the limit of sine 2x over sine 3x when x approach to 0. Divide the numerator and denominator by x, then the limit will be limit x approach to 0 for sine 2x over sine 3x over x. We divide the numerator and denominator by x. Now multiply the numerator by 2 and divide by 2. Multiply the denominator by 3 and divide by 3. Now, the limit will be limit 2 limit x approach to 0 for sine 2x over 2x over 3. Since it is constant, I'll take it outside the limit. Limit sine 3x over 3x when x approach to 0 equal to this limit is equal to 1 and this limit is also equal to 1, then the answer will be 2 over 3. Number 19, if f of x equals square root x, find this limit delta x approach to 0 for f of x plus delta x minus f of x over delta x. The limit will be f of x plus delta x. Since f of x is square root x, then it will be square root x plus delta x minus f of x. F of x is square root x over delta x. Limit delta x approach 0. If we substitute delta x with 0, then the answer will be 0 over 0. But since we have 2 square root in the numerator, I can multiply by the conjugate of the numerator. The conjugate is the same value with the reverse sign. X plus delta x plus square root x over x plus delta x plus delta x equal to limit delta x approach 0 for square root x plus delta x times square root x plus delta x is x plus delta x. Negative times positive is negative. Delta square root x times square root x is x over delta x times square root x plus delta x minus plus delta x. X minus x 0, delta x with delta x, then the result will be limit delta x approach 0 and the numerator 1 and the denominator square root x plus delta x minus plus square root x. Substitute now every delta x with 0. The answer will be 1 over delta x over square root x plus square root x 1 over 2 square root x. Question number 20. If f of x equal 4 over x, find limit delta x approach 0 for f of x plus delta x minus f of x over delta x. The limit will be limit delta x approach 0 for f of x plus delta x will be 4 over x plus delta x minus f of x 4 over x over delta x. If we substitute delta x with 0, then 4 over x minus 4 over x, 0 over 0. But since we have three fractions, we can unify the fractions. Unify the two fractions in the numerator. The limit will be limit delta x approach 0. The common denominator is x plus delta x. The numerator will be 4x minus 4 times x plus delta x over delta x equal to limit delta x approach 0 for 4x open this bracket minus 4x minus delta x over x delta x times x plus delta x. 4x minus 4x delta x with delta x. The result will be limit delta x approach 0 for negative 1 in the numerator over x times x plus delta x. Sorry, negative 4 delta x. Since 4 times delta x, it is 4 delta x. So the numerator will be negative 4 over x times x plus delta x. Now substitute delta x with 0. The answer will be negative 4 over x power 2. Question number 21. Find the limit of the function x e to the x minus e to the x over x minus 1 when x approaches to 1. If we substitute, the denominator will be 0. Then I'll try to analyze the numerator as limit x approach to 1 factorized by e to the x. Then from the first term will be x, second term will be 1 over x minus 1. Reduce x minus 1 with x minus 1. Substitute every x with 1. The answer is e to the 1 equal e. Question number 22. Find the limit when x approaches to 1 for this function x power 2 minus 2x plus 1 over x minus 1 absolute value. If we substitute 1 in the denominator, the answer is 0. Then we should analyze the numerator and remove the absolute value from the denominator. The absolute value x minus 1 equal to x minus 1 when x greater than or equal 1, negative x minus 1 when x less than 1. Now, the limit will be limit x approach to 1 for analyze the numerator by experiment x positive negative, so it is negative 1 over x minus 1 absolute value. Now, if we want to remove this absolute value and find the limit, then we should find it from left and from right, since the joint point is 1 and the limit approach to 1. Therefore, we will find the limit where x approach to 1 from left. Then the answer will be x minus 1 times x minus 1 over from when x approach to 1 from left, then it is x less than 1. Then I substitute instead of absolute value x minus 1 minus x minus 1. Then the result will be reduce x minus 1 when x minus 1, substitute every x with 1, 1 minus 1, 0, 0 over 1, it is 0. The limit when x approaches to 1 from right, it will be x minus 1 for x minus 1 over, from right it means x greater than 1. Then absolute value x minus 1 will be x minus 1. Reduce x minus 1 with x minus 1, substitute every x with 1, 1 minus 1, it is 0. Since the limit from left equal to the limit from right, then the limit is 0. Question number 23. Find the limit when x approaches to 0 for absolute value x plus 2 minus absolute value x minus 2. If we substitute x with 0, then 0 plus 2, absolute value 2, 2, minus 0 plus minus 2, minus 2, absolute value minus 2, 2, 2 minus 2, 0 over 0. Then I should remove this absolute value and open the bracket to find this limit. As you know, x plus 2, absolute value equal to x plus 2 when x greater than or equal negative 2, and negative x plus 2 when x less than negative 2. And x, absolute value x minus 2 equal to x minus 2 when x greater than or equal to, and minus x minus 2 when x less than 2. Now, limit x approach 0 will be when x approach to 0, 0 belong to this interval or this interval. 0, it is greater than negative 2. Then I'll substitute absolute value x plus 2 with x plus 2 minus absolute value x negative 2 when x approach to 0. X approach to 0 belong to this interval or to this interval. X approach to 0, it is 0 less than 2. Then substitute absolute value x minus 2 with negative x minus 2 over x equal to limit x approach 0 for x plus 2, negative times negative, positive x minus 2 over x, negative 2 with a plus 2, limit 2x, x plus 2, 2x plus x, 2x over x when x approach 0, x with x, and limit 2 when x approach to 0 equal 2. Question number 24. Find the limit when x approaches to 0 for absolute value x over x. When we have absolute value in the function, we should remove the absolute value to find the limit if the denominator became 0. Now, if we substitute directly every x with 0, it became 0 over 0. Then the absolute value is x when x greater than equal to 0, negative x when x less than 0. And find the limit from left and from right, since the joint point is 0 and the limit approach to 0. From left, it means x less than 0. Then absolute value x is equal to negative x. It will be negative x over x. The answer is negative 1. For the limit when x approach to 0 from right, then absolute value x equal x. will be x over x equal to limit 1 when x approaches to 0 from equal 1. Since the limit from left not equal to the limit from right, then this limit does not exist. Question number 25. Which statement is false for this function? Limit f of x when x approaches to negative 1 exists. When x approaches to negative 1 from left, then the limit negative 1 from left, I substitute in this segment negative 2x minus 3 over 2. Substitute every x with negative 1, then negative 2 times negative 1 minus 3 over 2. Negative 2 times negative 1, it is 2. 2 minus 3 over 2, it is 4 minus 3 over 2, 1 over 2. It is exist. Sorry. Let me find the limit for x approach to negative 1 from right. From right, it means x greater than negative 1. Then I'll substitute here in this segment 1/2 x plus 1. Then the answer will be 1/2 times negative 1 plus 1 equal to negative 1/2 plus 1 equal to 1/2. So this statement is true. Limit f of x exists when x approaches to 5 from left. From left, it means x less than 5. Then I substitute 5 here in this segment. Limit x approaches to 5 from left for 1/2 x plus 1 equal to 5 over 2 plus 1 equal to 7 over 2. It is exist. It is true. C. Limit f of x when x approaches to negative 1 from left is negative 1. We find it here when x approaches to negative 1 from left, it is 1/2, not negative 1/2. Then this statement is wrong. Limit f of x when x approaches to negative 1 from right is 1/2. It is 1/2 true. Then the right choice is C. Question number 26. Which is false? Which of this statement is false for the function f of x? Limit f of x when x approaches to negative 1 equal negative 2. X approach to negative 1. Negative 1 is less than 0. Then I'll substitute here negative 1. Limit x approach to negative 1 for x minus 1 equal negative 1, negative 1 equal to negative 2. So this statement is true. F of 2 equal negative 2. F of 2. 2 belong to this interval. It is greater than 0, less than or equal to 3. Then I'll substitute here f of 2 equal to 2 minus 2 square equal to 2 minus 4 equal to negative 2. So this statement is true. C. Limit f of x when x approaches to 0 from right equal to 0 from right, it means x greater than 0. Then I'll substitute in this statement. Limit x approach to 0 from right for 2 minus x square equal 2 minus 0 square equal 2. So this statement is also true. Limit f of x when x approach to 3 equal 1. X approach to 3, I must find it from left and from right. From left, it is limit x approach to 3 from left when x less than 3, 2 minus x square equal to 2 minus 9 equal to negative 7. But limit when x approach to 3 from right, then I substitute here when x greater than 3. For absolute value x minus 4 equal to 3 minus 4, it is absolute value negative 1, it is 1. Since the limit of the left not equal to the right, then this limit does not exist. Then the right choice is number D, which is false for this function. F of 2 defined. F of 2, then 2 belong to this interval. Then I'll substitute here f of 2 equal to 4 times 2 minus 5, 8 minus 5 equal to 3. Defined. It is true. Limit f of x exists when x approach to 4. When x approach to 4, then I must find it. Since 4 appear here and here, then I must find it from left and from right. Limit x approach to 4 from there, it means when x less than 4, then substitute in this segment 4x minus 5 equal to 4 times 4, 16 minus 5 equal to 11. When x approach to 4 from right, it means x greater than 4, then I substitute here 2x plus 3 equal to 2 times 4 plus 3. 8 plus 3, it is 11. Then the limit exists. Limit f of x when x approach to 2 exists. When x approach to 2, also 2 appear in 2 interval, then I must find it from left. From left, it means when x less than 2, 2x minus 1 equal to 2 times 2 minus 1, 4 minus 1, 3. Limit x approach to 2 from right, when x greater than 2, then I substitute in this segment 4x minus 5 equal to 4 times 2 minus 5, 8 minus 5, 3. Then also is true, then the right choice is none.